we have talked about matter, we have talked about mole concept also, which we will again see as we move along in this chapter of some basic concepts of chemistry. Now, we have learned that as we look around our surroundings, environment, we see substances of different textures, different shapes and sizes, correct? And all those substances are made up of some material which scientists named as matter. Also, we have learned that the definition of matter can be given as anything which occupies space and contains mass can be termed as matter. Correct? Now today we will try to understand what are the different physical states of matter and what are the classification of matter on the basis of macroscopic level or bulk level. Correct? Now starting with physical states of matter, we have seen in our lower standards also that there are three different physical states of matter, that is solid, liquid and gas. So how to define them, how to differentiate them with each other. Okay, I have written over here, if you can see, different physical states of matter: solid, liquid and gas. Great. Now what is a solid? A solid is a matter which has definite volume or definite shape. For example, if you consider, suppose if you can see this chalk, if you consider this as a solid, it has a definite shape, it is cylindrical shape and it has a definite volume. So a solid is a matter which has definite volume and definite shape. Whereas if we talk about the second state of matter, that is liquid, if you pour a liquid into, say, a cylindrical form of bottle, then it will have a definite volume, correct? Why? Because that shape of the bottle is cylindrical, and now since you have poured the liquid into that cylindrical form of bottle, then the shape of the water is now cylindrical. But if you pour that same water into, suppose, a spherical form of container, then it will have a definite volume, and that the volume of that liquid will be exactly the volume of sphere, but the shape has changed. Earlier it was cylindrical form of that liquid, now it is a spherical form. Earlier it was having a definite volume, that volume has been converted into a sphere, but the shape has changed. So what we can say is, in liquid have definite volume but not definite shape, correct? Whereas if you talk about gas, it does not have any definite volume or definite shape. It can have any shape and it can have any volume. So these are the different physical states of a matter, and where physical states of this matter: solid tells us that it has definite volume and definite shape. Liquid tells us that it can have definite volume but not definite shape. It can take any shape you want it to take. You pour into in any shape, it will take the shape of that particular container itself. Whereas a gas does not have a definite volume or a definite shape. Correct? Now these states are interchangeable. A solid can be converted into liquid, a liquid can be converted into a gas can be converted into liquid, and a liquid can be converted into solid. Also, a solid can be directly converted into gas, but it requires some process of heating or cooling. I have drawn it over here, if you can see: solid, liquid, gas, and these arrows represent some process by which solid can be converted into liquid and liquid can be converted into gas. Also, gas can be converted into liquid with some process, and liquid can be converted into solid by some process. Now, if you move from left to right, if you want to convert a solid into liquid and liquid into gas, then it requires heat. So all these processes from going from left to right is actually based on heating. Whereas if you want to convert gas into liquid and liquid into solid, then these processes require cooling. So what it reflects is, as you move from solid to liquid, liquid to gas, then the process is based on heating, and as you move from right to left, that is gas to liquid and liquid to solid, then the process are based on cooling. Correct? Now you might have seen in this lower standards also. So when you convert solid into liquid, then basically you have to heat the material, the solid, and the process is called as melting or fusion. So melting or fusion is a process by which a solid matter can be converted into the liquid matter. Whereas if you want to convert the same liquid matter into gas matter, you have to further heat it, and that process is called as evaporation. Conversion of liquid state of a matter into gaseous state or vapor state, that process is called as evaporation, and it requires more heat in comparison to what heat it has required for changing the state from solid to liquid state. On the other hand, if you talk about reverse processes, if you want to convert a gas into liquid form, then that process is called as liquefaction or condensation. That condensation can be done, that liquefaction can be done on the basis of cooling. If you cool a particular amount of gas, then the molecules of that gas will come close to each other and will be converted into the liquid form. Whereas if you want to convert that liquid into solid form, you require further cooling, more amount of cooling than it was done when gas was being converted into liquid. Now, since this liquid is going to be converted into solid form, this process is called as solidification, and more amount of cooling is required than it was required when gas was being converted into liquid. This process is called solidification or also freezing. Whereas if you want to convert solid directly into a gas form, then this process is called sublimation or sublimation, whichever way you want to pronounce it. This solid can be directly converted into gas through sublimation process. You might have seen camphor at your home or in temple. That piece of camphor when burned directly gets converted into gaseous form or vapor form. That process is called as sublimation. So these are the different processes with the help of which we can convert one state of matter into another state. By melting, we can convert solid into liquid form. For example, if you melt a piece of ice, then that solid form of ice gets converted into liquid form of ice. It requires some heat. If you further heat that liquid form of water, it will be converted into vapor form of water or gaseous form of water, and that process is called as evaporation. It will require more amount of heat. So moving from left to right is a heating process, and similarly, if you want to convert the gas form into liquid form, suppose you have converted some amount of liquid into gas form, if you want to convert that form of gas into liquid again, you will have to cool down that gas, and on cooling the molecules of gas will come close to each other and will be converted into liquid form, and then this process is called as liquefaction or condensation. Whereas with the help of solidification or freezing, you can convert liquid form of that particular amount or volume of water into solid form, and it requires further cooling. So right to left, movement of right to left process is based on cooling. Whereas, like I have mentioned the example of burning of camphor, that piece of camphor directly gets converted into gaseous form, and that process is called as sublimation. So we have just talked about different physical states of matter, that is solid, liquid and gas, whereas solid has definite volume, definite shape, whereas liquid can have definite volume but will not have definite shape. It will take the shape of the container the way it is. And a gas cannot have definite volume or definite shape, and these are the different physical processes by which we can convert one form of state of matter into another. Now let us talk about the classification of matter at bulk level or at macroscopic level. Okay. Now matter can be classified at bulk level or macroscopic level into mixtures or pure substances. Now what is the difference between a mixture and a pure substance? Mixture may contain components at any ratio, or that ratio can be variable. A mixture may contain components at any ratio, and that ratio can be variable. Whereas a pure substance contains component at a fixed composition ratio. Correct? So Mixtures differ by pure substances in the way we say that in mixture components can be in any ratio or that ratio can be variable, whereas pure substances contain components in a fixed composition. Now, mixtures can be further classified as heterogeneous mixtures or homogeneous mixtures. We'll try and understand what is the difference between heterogeneous mixtures or homogeneous mixture with the help of an activity or example. Suppose you dissolve some amount of a teaspoonful or 2 teaspoonful of salt into a glass of water and you mix it thoroughly. After some time, you will find that salt has disappeared and that particular volume of solution of salt in water, you can see that the composition can be seen as uniform throughout the volume. Its composition does not change. That particular solution of salt or sugar, if you have taken, is actually a homogeneous mixture where the composition is same throughout the volume. Now suppose you have a glass and you pour some cereals of grains, for example, and you pour some pieces of pulses into it, okay, and you shake that glass well. After some time you will find you can see the different composition of grains and pulses at different levels. It means that mixture is a heterogeneous mixture. A mixture of grains and pulses in a glass can be seen as variable, and that particular mixture is called as heterogeneous mixture. Whereas if you dissolve some amount of salt or sugar in water, then you cannot differentiate the composition at different levels of the volume. That means that mixture is a homogeneous mixture. Whereas pure substances can be classified as elements or compounds. I'm sure you might have heard about elements and compounds. Elements contain same type of atoms of a particular matter, correct? Whereas when atoms of different elements combine in a fixed ratio, they form compounds. So compounds is a composition of different elements, whereas elements have atoms of same type. They are identical in nature, in properties also and in mass also. But since compound contains atoms of different elements, they may show identical properties, but they are not same or identical in terms of mass.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment, and make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group, and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
Now let us talk about the properties of matter. What are the different properties of matter and how they are different from each other? Okay, different classification of properties of matter. Now, properties of matter can be of two types, that is physical properties or chemical properties. Friends, in our lower standards, we have learned that there are several types of changes occurring in our environment, which we see in our day-to-day life in our surroundings. Correct? Like rising of sun, setting of sun, our growth of plants and trees, food being cooked from raw food to cooked food, change in color of iron pieces, change in color of many things as time changes, and etc. etc. There are many changes which we see. Those changes can be of two types, that is physical change or chemical change. We have also learned in our lower standards that whenever physical properties of a substance changes, then we say the change is a physical change, and in that case the most important point to be noted is the identity of the substance does not changes. Whereas whenever the internal properties of a substance changes, then new substances are formed and the substance loses its identity, and that type of change is called as a chemical change. Correct? And it tells us that definitely some type of chemical reactions are involved in that particular chemical change, and there are several ways on the basis of which we can say chemical reaction is occurring or not, like change in color, change in temperature, change in state, and whether a gas has been involved or not. Similarly, we'll try to see what are the different physical properties and chemical properties of matter. See, whenever we talk about shape, size and state of a matter, of a substance, then we say that we are talking about physical properties of that substance. Even when we talk about the color, order, then we also say that we are talking about the physical properties of that matter, including boiling point, melting point and density. Okay, but in case of chemical properties, you see there is always a chemical change required, right? Just before we have started with physical and chemical properties, I have just explained that whenever there is a chemical change, then only we can say that chemical reactions are occurring. For chemical properties, we require some or the other chemical change, and there are some properties which falls under this category of chemical properties, like acidity, basicity, combustibility, etc. And also, when chemical changes are taking place, we know that new substances form. For example, if you take a piece of coal, if you burn that piece of coal in presence of excess amount of air or oxygen, then CO2 will be released and left behind will be ashes. Correct? Now, carbon, that piece of coal, has lost its identity. The carbon trapped in that piece of coal was earlier in solid form, which has been converted now as CO2 as a gaseous form. Carbon is now being converted into gaseous form and left behind are ashes. Correct? So new substances are formed, and that is why we say the substance loses its identity in chemical properties, where in physical properties substance does not lose its identity. So when we talk about the properties of matter, which we have just seen, physical properties and chemical properties. Physical properties are the properties where we talk about shape, size, state, color, order, melting point, boiling point and density, etc. In physical properties, a chemical change is not required, the substance does not loses its identity, and chemical properties require a chemical change to occur. New substances are formed, and we can say definitely a chemical reaction has been involved in that. And also we can say that the substance loses its identity. Those properties like acidity, basicity, combustibility. I've given an example of burning of piece of coal also. Now, when we talk about the properties of matter, there are certain properties like length, area, and volume which are to be measured, correct? And those comes into quantitative aspect of properties of matter. So, a quantitative measurement actually So a quantitative observation or measurement is represented by a number followed by a unit in which it has been measured. Now there were two different systems which were used earlier for measurement, that was English system and metric system. Now metric system was more convenient than English system because it was based on decimal system. It was originated in France in late 18th century and it was based on decimal system. But there was a requirement, there was a need for a common system for measurement. In year 1960, International System of Units, which we now betterly know as SI system, was introduced. Here are some features listed for this SI system. It was established by 11th General Conference on Weights and Masses, correct, in year 1960. It contains 7 base units pertaining 7 fundamental scientific quantities. These scientific quantities I have listed over here in a tabular form, which will I explain once we finish the features of SI system. SI system was established by 11th General Conference on Weights and Masses. It contains 7 base units pertaining 7 fundamental scientific quantities. It allows the use of prefixes to indicate multiples or submultiples of a unit. Multiples or submultiples means like kilo, mega, correct? And submultiples means milli, nano, picometers, pico, fermi. Those are submultiples. When we increase the power of 10, then it becomes multiples. We decrease the power of 10, then it becomes submultiples. Now here is a tabular form which tells us there are 7 base units like length. You can see in written in blue color: length, mass, time, electric current, temperature, amount of a substance, and luminous intensity. These are 7 base units, correct? Now length, mass, time, electric current, temperature, amount of a substance, and luminous intensities, 7 base units. After which I have written symbols for them. These are the symbols for 7 base units. For length we use L, small l letter. For mass we use small m letter. For time we use small t. For electric current we use capital I. For temperature we use capital T as a symbol of base unit of temperature. For amount of a substance we use small n, that we will come to know as we study about mole concept. Already we have just taken a gist of mole concept. Mole is represented by small n. And luminous intensity represented by capital I with suffix V. Only capital I means current and capital I with suffix V means luminous intensity. These are the symbols for these 7 base units respectively. Also, the unit which we use for these base units are: for length, where the symbol is L, the unit is meter, SI unit. For mass, the symbol is small m and the SI unit is kilogram. For time, the symbol is small t and SI unit is second. For electric current, the symbol is I and SI unit is ampere. For temperature, the symbol is T and SI unit is Kelvin. You might have heard about Kelvin, degree Celsius and Fahrenheit. the SI unit for temperature is Kelvin. For amount of a substance where the symbol is N, that we have seen in mole concept also, and we'll further elaborate as we'll study about mole concept in this chapter. For amount of a substance, the symbol is N and the SI unit is mole, whereas for the seventh base unit, that is luminous intensity, the symbol is I with suffix V and the SI unit is candela. Okay. Now the fourth column which you see over here written in white color are actually representing the symbol for these units of these seven base fundamental units. For meter we use small m. Do not get confused. Small m as a symbol of mass and small m is also for symbol of this unit meter, but meter represents length. So when we talk about mass, we also use small m, but when we talk about length and the unit of length is meter, the symbol of meter is small m. Also, for kilogram we use the unit capital K small g, that is kg. For second we use small s. For ampere, that is for current, we use capital A based on initial of ampere. And for temperature we use symbol as T, unit of which is Kelvin, and the symbol of that unit is capital K. For amount of a substance we use small n as a symbol. Unit of that amount of substance is represented by mole, M-O-L-E, and the symbol for that word M-O-L-E is just you omit the word small e and the symbol will become M-O-L, that is mole. And for luminous intensity, where the symbol is capital I with suffix V and the unit of which it is candela, has the symbol C, capital C and small d for this word candela. So when we talk about properties of matter, there are certain properties which are supposed to be measured or which comes into quantitative aspect of matter. So a quantitative measurement is represented by a number followed by the unit in which it is measured, and we have SI system. Earlier we had English system and metric system. Metric system was originated in France in late 18th century, and it was based on decimal system. It was far convenient than English system, but there had to be a common system which was required, and in 1960 in came the international system of unit, that is also called as SI units. Here are some features we have discussed, and also we have talked about the seven base units. We have seen their symbols also. We have seen the units of those seven base units and the symbols for those units also.